Alright, so I think I'm recording. Um, when I was doing problem number 1, I stopped. I did A and B and then stopped. I think there's several more parts to the problem. Sorry about that. Yeah, I did A and B and then I stopped. Alright, you're probably like, hey, is he going to do C and D? Sorry about that. Okay, so the domain of this composition. Two things have to be true with a function composition. Remember that with a function composition, I like to describe it as an assembly line, that you're applying these functions in a specific order. That we're taking some number and we're plugging it into. Now you have to be aware of the notation. You don't use the first function first, you actually use the second function. That's the way they've defined it. So the first thing that has to be true is that x has to be in the domain of g. Now, if that's true, you'll have an output. If it's not in the domain of g, you will not have an output. You won't be able to go any further in the problem. So if x is an element of g, then g does its magic. Maybe it's, well, here for this one it's 1 divided by the input plus 4, and so then out will come a number. That number is going to go into the function f. So what has to be true in order for it to have an output? This g of x has to be in the domain of f. If it is, then we'll get an output. If it's not, we won't. Alright, so we've already found that the domain of g was all real numbers excluding -4. Now, when the output of g goes into f, f is not picky at all. F has a domain that's all real numbers. So we don't have any further restrictions to worry about. So the domain of this composition, the only thing that we have to worry about is just getting our number through the function g to have it well defined. So the domain of our composition is the same as the domain of g, all real numbers except -4. And a lot of these, the domain of the composition, is going to be the domain of g whenever the domain of f is all real numbers, and a lot of times even in other cases too. So I think on this next one we find the domain of the composition in the reverse order. Yeah, golf, g composed with f. So whenever we're doing the domain of a function composition, two things always have to be true. X, our input into the function, has to be in the domain of this first function, which in this case is f. So if x is in the domain of f, then we'll have an output. Otherwise, we won't have an output. Now this becomes the input into the next function, so it has to be in the domain of that function. F of x has to be in the domain of g, or otherwise we do not get an output from this function. The domain of f was all real numbers. There's no restrictions at all. We can put anything we'd like into f, and it will multiply it by 3 and then add 5, and it will produce a y value. Now, when that output of f goes into g, we have to look at the domain of g. We know that the domain of g is all real numbers excluding -4. But I'm not going to throw out -4 from the domain here, because when I plug in -4 into f, the output of f, it won't be -4. It'll be whatever -12 plus, it'll be -7. What I have to figure out, I have to prevent f of x from ever being -4, because I do not want g to ever see -4 as an input, because when I try to input -4 into g, what comes out is 1 over 0, and that's not a real number. So we temporarily set this equation equal to -4. F of x, we know, is 3x plus 5. If that were allowed to equal -4, we'd have trouble. If I subtract 5, I get -9. So x equals -3. Well, I don't want that to happen, and think about why I don't want that to happen. If we try to input -3 into this function composition, what would happen? Well, if you have g composed with f at -3, when you evaluate f at -3, you don't have a problem at all. You've got 3 times -3 plus 5. That's -9 plus 5, so that's a -4. So when you go to evaluate g at -4, you have a problem, because that's 1 over -4 plus 4. And that's undefined because that's 1 over 0. You know, even trying it on your calculator, you can't find a number here. It's undefined. So if you go to look at the graph of g composed with f, when you're plotting -3, there's no corresponding y value to plot here. It's undefined. So therefore, we can't let -3 be in the domain. And it's not because of f. When we plug in -3 into f, we get a -4. But the -4 into g causes us problems. To prevent those problems, we have to go back to the starting point here and prevent x from ever being -3. Alright, so I hope that helps. So let's write down our answer in interval notation. The domain of golf is all real numbers excluding -3. Alright, so when I do problem 2, I'll try to do the whole thing on one video. There's my final answer for part D, and I hope that helps.